Color creation. Every morning, when we open our eyes, we see beautiful colors around us. Let's learn a little bit about color and its creation through an easy science experiment. As we can see, this is a pH scale having different colors on it. Number 1 is red. Number 4 is orange. Number 7 is green. Number 10 is blue. Number 14 is purple or violet. There are special chemicals called indicators which can change their color on the basis of their pH. A lower pH from 1 to 6 is called acidic. For example, lemon juice, hydrochloric acid, or any other acid, and so on. And a higher pH on the scale is called basic or alkaline, from 8 to 14. For example, sodium hydroxide or baking soda. pH 7 is called neutral. For example, water. While most indicators have a specific and small range, there is also a universal solution that can be used to measure pH all the way from 2 to 14. Let me give you an interesting situation. Let's imagine that your school has run out of water-based paints just before the annual function, and there is no time to order new stocks. They need colors on an urgent basis. Fortunately, the chemistry lab has some leftover hydrochloric acid and sodium hydroxide, as well as a universal indicator solution. Now, what should we do? I have an idea. Let us see can help us here how understanding pH. The requirement is to create various colors using only a universal indicator solution and two chemicals on the opposite ends of the pH spectrum. To get the desired colors every time, we can design a recipe with these three chemicals that will allow us to make the same color each time we require. But how? Since we already know that indicators can change their color on the basis of pH, adding more of the hydrochloric acid, also called HCl, to the already green universal dye will gradually make it yellow, then orange, and finally red. But if we add the sodium hydroxide, called NaOH, it will change to blue-green, blue, and then violet. We can take the same amount of the indicator solution in different tubes and slowly add different amounts of the two chemicals to get the desired color. In this manner, we can prepare all the 6 colors. By optimizing a reliable recipe, the school can then scale up this experiment to make more of the same paints just in time for the function. It is important to note that this experiment is only to understand color and pH, and these are not actually paints that can be used. Can anyone tell us why and what exactly is present in the real paints? These chemicals cannot be used since they have strong acids and alkalis that will simply corrode the paper. And real paints contain 3 things: a pigment, which is the color, for example, titanium white, or sunset yellow, a neutral base, and a binding agent. Also, please take care that HCl hydrochloric acid and sodium hydroxide are dangerous chemicals and must be handled with extreme care.